In this video, we're going to draw the graph of a quadratic function whose shape will be a parabola. We're given the function f, where f of x equals negative 3x squared plus 6x plus 2, and we'll go through a series of steps to create this graph. The first thing we'll do is determine if the parabola opens upward or downward. Then we'll find the vertex algebraically, and then we'll use that vertex to create a table of values centered around the vertex. And finally, we'll plot the points we can obtain from that table of values and connect them with a smooth curve to complete the graph. So let's get started. With regard to whether this opens upward or downward, we want to look at the leading coefficient. And so as we look at this, we see that we have negative 3x squared as the leading term. So that leading coefficient is a equals negative 3. So this parabola is going to open downward as a is equal to negative 3. It's a negative number, so that negative sign on the leading coefficient indicates that the parabola will open downward. To find the vertex, we're going to use x equals the opposite of b over 2a. So we have x equals the opposite of b over 2a, and we'll use that to calculate the x value of the vertex. Once we have the x value of the vertex, we can input it into the function and find the y value, or the output. So looking at this, with negative 3x squared plus 6x plus 2, if we want to take x equals the opposite of b over 2a, then the opposite of b is negative 6, since our value of b is 6. And then dividing by 2a, we're going to divide by 2 times negative 3, as the value of a is negative 3. So that'll simplify to negative 6 over negative 6, which just gives us a value of 1. So that we know now that the vertex occurs where x is 1. Next, we want to find the output. We'll do that by evaluating the function f at 1. So now we want to find y, and we'll do that. We'll take f of 1, and that will equal negative 3 times 1 squared plus 6 times 1 plus 2. So I've evaluated the function f at 1, and now I can simplify that. Negative 3 times 1 squared is negative 3. I'm adding 6 times 1, so I'm adding 6, and then on the end I'm adding 2. So when that's simplified, negative 3 plus 6 plus 2 gives us 5. So now we can summarize that the vertex is the point 1, 5. Okay, now we want to create a table of values for this function. And if we want points around the vertex. So let's center this table on the vertex. And so the x value for the vertex is 1. So we'll create our table. And I'll keep this in my standard coloring here. So I'm going to make a table. And I'll have an x value. I want the output value. And then I'm also going to add points to this. So I'm going to want x, and then I'll want the output, which is negative 3x squared plus 6x plus 2. And just to guide me in eventually creating that graph, I'm going to add a third column here with the point, so with the xy pair. Okay, so my vertex occurs at 1. So I'm going to put 1 in the middle of these x values. And then I want a couple points on each side. So going down, I'll go 0, negative 1, negative 2. And then going up from 1, I'll go 2, 3, and 4. And I may not put quite all of these on my graph, but I want to find some of these function values. So we know already that for 1, the output is 5. And so we're going to have that point 1, 5. So I filled that out in the table for x. When x is 1, that output value is 5, and that means that the point 1, 5 is on the graph. Filling out more of this table, let's start with negative 2. So we're going to evaluate negative 3x squared plus 6x plus 2 for x equals negative 2. So replacing x with negative 2, we'll have negative 3 times negative 2 quantity squared plus 6 times negative 2 plus 2. And looking at that, negative 3 times the number negative 2 squared is going to be negative 12. So I'm going to have negative 12 minus 12 plus 2, and that will sum to negative 22. I'm going to adjust my graph to make sure I can fit all of this in. Okay, so now that's going to equal negative 22. So the point would be negative 2, comma, negative 22. Looking where x is negative 1, I'll evaluate it in a similar manner. I'll have negative 3 times negative 1 squared plus 6 times negative 1 plus 2. And that'll simplify to negative 3 minus 6 plus 2, and that's negative 7. So the point is then negative 1 comma negative 7. Looking at 0, this one will be a little simpler. I'll take negative 3 times 0 squared plus 6 times 0 plus 2, and that's just going to equal 2. So it passes through the point 0 comma 2. Now, at this point, I know that my axis of symmetry passes through the vertex, so I should have symmetry in my table as well as my graph for points on each side and function values on each side of x equals 1. So I'll evaluate the first one, but then I'm going to use symmetry to complete the rest of this table. So if I plug in 2 for x, I'll get negative 3 times 2 squared plus 6 times 2 plus 2, and that's going to equal negative 12 plus 2, which is just 2. So this is going to pass through the point 2 comma 2. Now, that y value on each side, 1 unit on each side of x equals 1, was 2. And so this symmetry is going to repeat. So I know now, based on symmetry, that for x equals 3, the y value is going to be negative 7. And I'm looking at just moving 1 unit over to the left. And for 4, that y value should be negative 22. Again, I could have gone through the same calculation process if I wanted to. Here I just was able to use symmetry instead to shorten some of that work. So the points now are 3, comma negative 7, and 4, negative 22. So now I'm going to plot these, and I'm going to focus just on the center 5. I'm going to leave out negative 2, negative 22, and 4, negative 22. So scaling this grid, I've got an 8 by 8 grid, and I'm just going to make each unit, each tick mark worth 1 unit. So I'll label off my x and y axes, and then I'll mark off 4 and 8 at 4 units and 8 units on the x-axis. I'll do negative 4 and negative 8 in the other direction on the x-axis. And I'll do the same with y. I'll mark off 4 and 8 and negative 4 and negative 8. Now I'm ready to plot these points. So I'll plot the point negative 1, negative 7. I'll go to where x is negative 1 and y is negative 7. I'll plot the point 0, 2. So I'll go to where x is 2, or 0 and y is 2. I have that point 0, 2. Then I want to plot the point 1, 5. So we'll go to where x is 1 and y is 5. Next I'll plot the point 2, 2. So I'll go to where both x and y are 2. And lastly, I'll plot the point 3, negative 7, so I'll go to where x is 3 and y is negative 7. Now that these points are graphed, I want to connect them with a smooth curve. So I'll go to that vertex and I'll just draw a line pointing down, connecting them in a smooth rounded curve. Put an arrow on the end to show that it continues, and I'll do that from the other side of the vertex, connecting that piece. And that is the full graph of my parabola.